We're going to find the distance between the following points using the distance formula, which I have provided right here. We're going to give an exact answer in simplest radical form, and we want to show all of our steps. So let's start plugging in some values. For 8 is where we're going to start. We're going to have the square root inside of here. I'll use 2 as x2, and then I'll have minus 5 squared plus we have our y2, which is 4, minus y1, which is 10, and this is all squared. So inside of here, we're going to get a negative 3 from this. Negative 3 squared is going to give us a 9. So let's do a square root. We have 9 here, plus we're going to have a 6, or a negative 6 squared. So that's just going to be a 36 right here. Now, how do we have it in the simplest radical form? Well, a radical is this part right here. That's the radical. Let's add these two together and see what we get. We are going to, from this, get a 45. And what is the simplest, again, radical form? Well, a super easy way we can find this, super foolproof way, is to take 45 and break it down into its smallest components. We know that 9 times 5 is 45. We can't break down 5 anymore, so let's draw a line under it. That's going to represent the lowest possible thing it can be. And then we'll break down 9 to be 3 times 3. And you can't break this down anymore. Now, remember, a radical is really just the square root with 2 as the kind of factor out here. We have 2 3's, so that means we can bring a 3 out front, and then we will have a 5 on the inside. This makes sense because this essentially is saying, well, we have 2 3's, we're square rooting it, square root of 9 is just 3. So we have the square root of 9 outside being multiplied by the square root of 5. This is the same thing as square root of 9 times square root of 5. And that's essentially it. That's what we have right here to the left. So we have 3 times the square root of 5. That's the simplest radical form for it. Now let's do another one. Let's do number 9. We have, in this one, the square roots, and then inside of here, we're going to have our 2 minus a negative 4 squared plus our y2 is just going to be 1 minus a negative 7, and this is squared. So we have the square root of, we're going to turn this into a positive and turn this into a positive as well. And if we do that, we are going to have essentially 6 squared, which is 36, plus, this should be in a parenthesis, we're going to have 8 squared, and then 8 squared is just going to be 64. So we're essentially going to have the square root of 100 inside of here. So what is the square root of 100? Again, let's take this and break this into the most simplest parts. We can have 5 right here. 5 times 20 is 100. So I can't break this down anymore. And then 20, we're going to have 2 times 10. Can't break this down anymore. And this one we're going to have 5 and 2 right here. So if you look at it, we have 2 5's and 2 2's. And so essentially what we can do from here is just take out the 5's and the 2's, and if you didn't already know, the square root of 100 is just going to be equal to 10. So that was just a way to prove it. The square root of 100 is pretty common. The distance formula is something you have to remember. Square root of 100, super common thing. 10 times 10 is 100, and that's how you would get the square root of it. So the answer for this one would be 10. I just wanted to show you how this works and explaining how you can do this for any kind of radical problem.